The only comparator we have, unfortunately, is almost like the flu pandemic, 1918. Why I'm saying this? Because this was clearly a pandemic of a respiratory virus where there was no human intervention. Infection prevention measures were very, very, very limited. It was war on top. So you had crowding, you had very bad hygienic conditions, etc. And there was no vaccine. So there, first of all, what we have seen no variants. The whole thing happened within 1 year. And people have been sampling or analyzing autopsy samples to see whether there was any variation in the strains that, during this pandemic appeared in several different parts of the world. And it was very homologous. So that is one thing. Now, so that is very important, because this is a high infectious pressure, a natural pandemic, no human intervention. So if you imagine now that we have, like, every second or third week, we have a new infectious variant appearing. And not only is this a more infectious variant, it's very often also much more infectious, like the Brazilian compared to the UK, etc. And it all appears very rapidly. It's not like during evolution, of course, these things appear, and if they have a competitive advantage, they will replace the original strain. Now, all this is happening, multiple variants within a short period of time with dramatically increased infectivity. And this in parallel with the mass vaccination campaign. I mean, as I was saying, you have the same pandemic. Well, it was flu, of course. Nothing happens in terms of variants. There were a few mutations, but here the mutations are very clearly targeted. They are selected at domains that enhance the infectivity virus. So they are not like random. They are really selected towards parts of the spike protein that are responsible for infectivity. So, I mean, there is something there, right?
Oh, yes.
As I was saying, we need to agree upon this. Same, for example, if you imagine now the situation in Chile, for example, okay? So you're vaccinating on a background of a variant that had just appeared, right? I mean, the Brazilian variant. So this Brazilian variant is, of course, pretty much different, the S protein, from the S protein of the vaccine. If you now start vaccinating people, of course, this variant that just emerged is going to have a competitive advantage because it's more infectious, and what you want to do with your antibodies is to prevent infectivity. So now all of a sudden you see how this variant is exploding, and you see the infectious rates that are dramatically increasing. So all of a sudden you have a much higher infectivity rate, right? And so there is other criteria as well that we could, the mutations are of course studied. We see more and more that they are also now converging towards domains that are targeted by the vaccinal antibodies. So if you take all these things together, we should be able, compared, as you pointed out correctly, to a natural pandemic, to observations that are really high, very, very strange, and that, according to my humble opinion, could be correlated with at least, I would say, human intervention, right, in this pandemic.
So if I can make that a little bit simpler, what you're saying is, A, something that surprised me the first time I heard you say it, which is that in the 1918 pandemic, there were no widespread variants. And we know this from the comparison of samples taken during autopsy. So that shocks me. I think what it suggests is that the evolutionary experimentation took place before the pandemic, that effectively the virus got very effective at transmitting in some small population that wasn't captured in the autopsy samples. Maybe it wasn't even recognized as a unique disease. And that by the time it circulated around the globe, it was already highly effective. And that in this case, we have, well, I would say the anomalous fact of this virus apparently having emerged in the human population already highly effective, We have no evidence for that experimental evolutionary period at the beginning, which is one of the reasons that many of us believe the laboratory origins hypothesis is probably correct. But in the context of this vaccine campaign, what you're arguing is that we are seeing exactly the pattern of change that you would predict if we were creating this inadvertent serial passage experiment in the human population. We are putting pressure on the spike protein in this narrow way. We are seeing change in the spike protein and in exactly the domains that would cause immune escape. And that, let's put it this way. I think the presumption would have to be that we are driving that change, or at least accelerating that change, by virtue of the very intense and very narrow evolutionary pressure that we are applying to the virus.
Well, frankly speaking, Bret, if you would ask me, set up an experiment where you adapt a variant to immune pressure, but do it in humans or do it in a mammalian population, what would you do? You would, of course, first of all, make sure you have a high viral load. You would make sure that as many people as possible are in the same situation of a suboptimal immune response. And I mean, if you can already start with variants where the match is already suboptimal, then it's even better, right? So that is exactly what you would do. That is exactly what you would do to adapt a variant. And what is worrisome, Bret, is the kinetics of all this. This is all going very, very fast, right? I mean, the emergence of all these variants, and I mean, as I was saying, there is probably a whole series of variants that have not been identified yet, but it's not like any variants. Many of these variants are selected towards, for example, a higher infectivity. And when we come now more and more with antibodies, etc., we see already that some of these mutations are abolishing the effect of certain antibodies within the polyclonal serum of the vaccinal antibodies. So it is very well directed. It is fast. It is pretty huge because, I mean, as I was saying, if there is a mutation just by an antigenic drift, for example, and that mutation happens to be a little bit more infectious than the original strain, then in the course of time, it will take over. But this will be pretty slow, right? Evolutionary speaking. Here, these things are like accelerated, enhanced, and it's difficult to deny that this is not really in parallel with the mass vaccination campaigns or with human intervention. Because as I was saying, during the flu pandemic, nothing was seen. And you could argue as well, people must have mounted antibody responses, right? During the flu pandemic. I mean, it was not like there was no immune response.
So you have said if you were going to set up an experiment to induce the effectively gain of function here, it would look more or less like this campaign. I would say evolutionarily, we can describe this very simply, that effectively we have given the virus a gentle evolutionary slope for which it can discover high infectivity and escape from immune surveillance. So that's all quite frightening, that not only does the pattern in the wild seem to match the fears of somebody who is well positioned to say, here's what you would expect to see if my hypothesis is correct about immune escape. So that raises a number of different questions. I mean, it raises the question about what should we be doing vaccine-wise?
Well, Bret, I'm a little bit hesitating if for a second we should come back to the innate immune response.
Oh, and because the connection to the young. Because
I mean, you could say, well, if there is immune escape, worst case scenario is that the vaccine won't work anymore. And that is then the other argument, we will produce new vaccines, right? But my main argument, really, that is my key argument, is that even though the antibodies may no longer neutralize the virus, they will still be able to bind to the spike protein. And all this is science, because people have been showing that, for example, antibodies against the common cold virus, right? They do not neutralize or cross-neutralize COVID-19, for example, or SARS-CoV-2, but they do bind. They do bind to the S protein, but they do not neutralize it. So if antibodies are no longer completely functional in the sense that they can neutralize the virus, they can still bind to the S protein. And there comes my big argument, and therefore we need to come back to these natural antibodies. By binding to the S protein, these antigen-specific antibodies are capable of outcompeting natural antibodies. And that is the disaster, because as we were saying at the beginning, the natural antibodies, they are not antigen-specific. They have the capacity to broadly neutralize not only all kinds of COVID variants, but even all types of coronaviruses. And maybe you want to jump in at this point to make it a little bit clear to the
Sure.
audience?
Yeah, this is such a fascinating point. But what we have is the possibility of antibodies that are ineffective at preventing the spike protein from binding the receptor, and therefore ineffective at preventing infection, that would nonetheless attach themselves electromagnetically. They would just simply stick to the spike protein, and they would block the innate immunity that we all have some degree of, and that young people appear to have a great deal of, and therefore take the immunity that works best and neutralize it without creating a new immunity that would take its place. And that's, again, it's a wild argument, but I see nothing wrong with it logically. Logically speaking, this makes a great deal of sense.
Well, Bret, I'm going to be very open with you. The field of natural antibodies is not well recognized or known in the field of vaccinology. It is well known by immunologists. Frankly speaking, there is dozens of papers on these natural antibodies and how fascinating they are. As I was saying, they are a little bit, in parallel to the NK cells, they recognize patterns. They recognize patterns of antigens. But this field is so neglected, so underestimated. I'm sure that many vaccinologists don't even really understand what natural antibodies are about and what they can do, because there is a lot of documentation on this, and there is even documentation. I will tell you, the nicest documentation is, about the blood groups, right? A, B, O, etc. So these blood groups, these are glycosylated structures, right? Glycans, sugars, for the people who don't understand what glycans are. And so, for example, if you have, if your blood group is O, for example, you will have antibodies, natural antibodies, all documented, all in papers, in publications. You will have natural antibodies against, for example, the blood group A. Blood group A is a sugar, and acetyl galactosamine, right? And so now, interestingly enough, if the virus is now grown in a cell, in a mammalian cell, in a target cell, that belongs to somebody who has blood group A, right? Then as the virus is budding, when the virus is leaving, it's released from the cell membrane. It has an envelope, of course. That envelope, because it's partly, part of the membrane of the target cell, it will also have this blood group A antigen. And when such a virus is encountered by somebody who has blood group O and who has natural antibodies against blood group A, the virus will be destroyed. And this has been proven, not for SARS-CoV-2, but for SARS-CoV-1, that these natural antibodies will prevent the virus and the S antigen from interacting with the AC2 receptor, right? I mean, it's not like there is no evidence, there is no points. Also, the binding forces between the multimeric natural antibodies and the specific antibodies are completely different. You know, the type of chemical bonds, the one is the multivalent interaction, which is much weaker than the S-specific binding, for example. I mean, there is many things documented. There is also very well documented that natural antibodies can prevent influenza infection against a whole range of variants. All this is in the literature. So it's not like I'm the crazy guy just inventing some stuff and putting pieces of a puzzle that doesn't exist in reality together to make a fancy story, right? It is really highly likely that if you have S-specific antibodies binding but not neutralizing your virus, that they can prevent the natural antibodies from acting on that virus. And that is, as you pointed out, your specific antibodies are no longer functional and you have no substitute for it because you put your natural antibodies out of business.